Well, hello again and welcome to the VK6CS Fun with Amateur Radio channel. Surprisingly, I'm still alive, so I thought I'd clarify what was happening in the previous video. You know, when I got those, or one at least, one peculiar effect when I was measuring those voltages. So first of all, I'll show you what was going on. Of course, the tripod's in the way, so I'm going to have to try and squeak in between the tripod and the board. So I've got no idea how well this is going to work. Certainly isn't very comfortable. Let's give it a crack anyway. I think. See, the trouble is now I've nudged the tripod. I don't know whether it's still in shot. So I've got to get up again. Okay, yeah, that's all right. Okay, so the first test was the mains comes in. It does actually go through an 8 amp fuse. It then goes through a 3.3 ohm resistor on each leg of the AC down to the transformer primary. And what was happening was I was measuring 235 volts here, like that, and I was measuring 229 volts here, and that was giving me the HT, when it was rectified, was giving me 2720 volts on the rectifier bridge and the smoothing capacitors. Okay, and that's exactly what I'd expect to see. So slightly less voltage here because you turn it on, and once the transformer is magnetised, the capacitor inrush current has passed. Be very little current actually going through here, so there'll be very little voltage drop across these resistors. 235 volts, 229 volts, so 6 volts is about what I'd expect to see. But the HT voltage was quite low. And I thought, well, that's 200 volts lower than it has been. So what's going on? And then I remembered that I'd actually put a variac. Previously I hadn't had the soft start in here, and I'd had the variac supplying the AC volts. So what I had was, I had the 235 volts goes into a variac, and because the variac is an auto transformer, you can actually get more voltage out of it than you put into it. So the winding on the auto transformer is like that. Okay, so 235 volts goes in like that, and then the wiper of the variac at maximum there, like that. That then goes through the 8 amp fuse, which goes through the 3.3 ohm. That's the 3.3 ohm as well. That then goes to my transformer primary, like that, 3.3 ohms. Now I put 235 volts in here, I actually get 248 volts here, because this variac auto transformer has increased it. What I didn't understand was, and I measured it more than once, I had 251 volts here. And that's what made me scratch my head. And that produced 2,900 volts DC when it was rectified and smoothed from the other side of the power supply on the secondary winding into the rectifier bridge and the smoothing capacitors. So I thought, okay, when I measured this one, the volts across the transformer primary, a few volts less than the supply volts on the other side of the resistor here, the resistors, exactly what I expected to see. When I fired it up with the variac, I really didn't expect to see 3 volts less here than I had there. You know, 3 volts less on the supply side than on the load side of the 3.3 ohm resistors, and that just did not make any sense to me at all. So anyway, that's what I had. I thought you might just find that interesting because I was scratching my head and I thought that just doesn't make any sense. So if that makes any sense to you, perhaps you can leave a comment. It may be that there's some sort of noise or something on the primary of the transformer, and these are wire wound 3.3 ohm 100 watt resistors, and they're actually acting as sort of chokes, so that noise doesn't get back onto here. So that measures a little lower because I'm not measuring the noise. Yeah, or it might just be I don't know. Maybe it's because of the magnetism of the primary. Something strange might be going on. But yeah, that's what I expected to see. That really isn't what I expected to see. And of course, you know, these resistors will be shorted out. I bought the relay today. The soft start relay will actually short these resistors out once the transformer is magnetised and the inrush current of the inrush current for the capacitors has been supplied. But looking at this, the transformer is supposed to be 240 volt in to give me 2000 volts out. My mains voltage here is only 235 volts, so it was last night when I measured it. And if you think about it, you know, 235 volts, that's probably a little bit more than 10% of the 2000, well it is, isn't it? It's more than 10% of the 2000 volts on the secondary. So when I recover my 6 volts, once these resistors are shorted out, I'm going to be less than 60 volts better off. So I said it was 2720 volts, so it's probably going to be 50 volts in it, so it's probably going to be 2770 volts. I think it was 2828 I calculated it should be, but that would have been with 240 volts in. So if the mains voltage ever comes up to what it's supposed to be, or I use the variac to set that to 240 volts, this to 240 volts, I should get 2828 volts DC out of the power supply. So there we are. That's just a bit of a quick explanation as to what I did yesterday and why I found it a little puzzling. So I hope you found that interesting, and I'll again thank you for watching, and I'll catch you next time.